right, guys. So today we're going to be doing a little bit of graphing. That's why you don't see me. You just see my horrible hands there. So I'm going to actually get rid of that webcam, the document camera, really quick, and we'll get back to it when we start graphing so you can't see my face. So we've already learned about production possibilities. What are we producing? What resources are we going to use, and for whom we are going to produce. And we've talked about the opportunity cost. What am I giving up to make one thing or buy one thing instead of making or buying some other thing? So today we're going to graph that. And graphing is kind of difficult, but I assure you that if you take down all your notes and you write down all the graphs, then you'll be in good shape as well, okay? That's why I have the document camera instead of my webcam today to kind of show you guys how to get this graphing done, okay? So let's talk about the graph before we actually dive in. What is production possibilities? Exactly what it sounds like. What is possible to produce? Essentially, we have a finite number of resources. We can't produce is another way of saying make, everything, and we have to choose. Factories have to choose. Businesses, firms have to choose. The government has to choose. Just like you choose what to do with your time, people that are trying to make money, turn a profit, have to choose how to produce things. And the production possibilities curve, which from here on out I'm going to be calling PPC, you see it right there, the PPC, compares two goods, and it graphs out how much of this good can we make if we're also making this sort of good. And I will show you. Now, these definitions are pretty important. You need to write them down. They will also be on your test. Think, I made your test, so I know what's on your test, so I know what you need to write down. So write this down. There are two types of PPCs that we're going to be looking at. Again, PPC stands for Production Possibility Curve. The first type of PPC is a constant cost. Constant. It is a constant line, okay? It is a graph that economists make when goods are made of similar resources, and it's a straight line graph. I'm going to show you an example here in a minute. So what goods would be made of similar resources? Here's my example. Chocolate bars and hot cocoa. Let's go back to my fanny pack example. Fanny packs and clothes are made out of the same thing, right? Fabric. Let's think a notebook and a binder are made out of the same thing. Paper, cardboard, those sort of things, okay? Increasing cost curve is our second type of PPC, our second type of production possibilities curve. And that is when goods are made of completely different resources, but we still have to limit our resources. They're still scarce resources. And this is graphed with a curved line. I'm going to show you a picture here in a minute. Guns and butter, not made with the same thing. A water bottle and a notebook, not made with the same thing. Just like really out there different resources. Germex and the sign in my room that says Mrs. Keller. Those are different things, different resources, but we still can't produce all of those things all the time. So there's going to be an opportunity cost, and that's what these graphs are going to show us. So these are two different types of graphs. Constant cost curve graph, increasing cost curve graph, and both of them are PPCs. So here is an example. This is a curved line, so that would be an increasing cost, PPC, okay? So here is an example, and I've got different points, A through F points on here. Cars and clothing made out of different things. Cars made out of metal, clothing made out of fabric. So different resources go into these. So what do these points mean on the PPC? Sometimes people call it the PPF, frontier instead of curve. We'll keep it to PPC, okay? So our first point says point C. All of the resources are being used to make clothing. 0 cars are being made. 0. Okay? We're putting everything into clothing. All right. Over here, point F, all of the resources are being made for cars. No clothing is being made up here because on this curve, we're not anywhere near clothing. We're all the way up here at cars. Okay? And there's nothing left for clothing. Point A is somewhere in the middle. We're making 70 cars and 300 sets, pairs, whatever, shirts, something, okay? Point B, we move along the curve. We're getting closer and closer to more clothing, and we're getting farther and farther away from more cars. So what's the number? Well, we follow those lines. We're making 400 of this clothing piece and 40 cars. So we've lost some cars in order to make more clothing. That's opportunity cost, okay? Let's take a look at point E. We're not using all our resources. We're not on the line here. we have more resources. We can jut out and make more and get on that line. That's inefficient. Point D is impossible. We don't have enough stuff to make this crap, okay? We don't have enough metal. We don't have enough fabric and zippers and sewing machines. So we cannot get to point D unless something changes, and we'll talk about that later in our unit. You do not have to memorize this. This will become stuck in your head anyway. Points on the line are efficient, and we just choose how many of this are we going to make versus how many of this. Points inside the line are inefficient. We are not making enough. We have more resources. Points outside the line are impossible unless something changes. Our economy just doesn't have enough resources for that. All right, so graphing opportunity costs on this PPC. Why do we do that? Because we want to know if we produce more clothing, how many cars have we lost? Remember, if we choose to do more of one thing, then we lose out on something else. That's our opportunity cost. That's something that we learned the other day. So when production of one good like clothing increases, the production of the other good must decrease. We don't have enough resources to do both. That is called the opportunity cost, and that's what we're going to be graphing. You see, when we moved from 300 to 400 pieces of clothing, we had to decrease the number of cars we made by 30. Yeah, my math's right. I had to check it. By 30, okay? All right, so let's dive in. I told you we were going to have two types of constant cost PPCs. Of production possibility curves. And today we're diving into one of them, constant cost PPCs. Remember, constant cost is a constant straight line on the graph, and it means that we're comparing goods that are very similar, like hot cocoa and chocolate bars. Okay, so here's that definition again. We are comparing on a graph two goods that are made with similar resources, fanny packs and backpacks, made with similar resources, a desk and a chair, made with similar resources. And we use this graph to try and find out if we make more desks, how many chairs are we losing out on? That's the opportunity cost of making one good versus the other. And this is graphed using a straight line. So let's take a look at what that looks like. All right, I'm going to switch on over to my webcam really quickly and show you how to do this. All right, I'm going to start you guys off with a really easy example here. So this exact pink slide that you see, I have copied right here, and I'm going to try and do the problems in different colors. So number one is going to be this purple pen, okay? So let's practice what this looks like. Again, this is a constant cost graph. Why is it constant cost? It's a straight line, constant straight line, okay? So let's start. From point A to point B, what is the opportunity cost of making one fanny pack? Okay, so we're looking at point A to begin with and going down to point B. What is the opportunity cost of one fanny pack? Well, let's start at point A and see where we are. At point A, we are making 4 Halloween costumes. 4 Halloween costumes. And 0 fanny packs. There should be a 0 here. So we are making no fanny packs at the expense, the opportunity cost making 4 Halloween costumes. If we move along the constant cost line to B, point B, then we are making how much of what? We follow the line. It's very simple. We are now making 3 Halloween costumes, follow the line down, and 1 fanny pack. So our question says, what is the opportunity cost of making 1 fanny pack? If I make 1 fanny pack, I go from 0 to 1 fanny pack, how many Halloween costumes from point A to B have I lost? That's pretty simple. I just got to look, what is 4 minus 3? It is 1 costume. I was able to find that on the graph. It was very simple. All right, let's go to number 2. Number 2 I'm going to do in this blue pen, okay? So from A to C, what is the opportunity cost of 2 fanny packs? Uh-oh, we're getting complicated now. So point A is my starting point. Point C is my ending point. What is the opportunity cost? What am I giving up to make 2 fanny packs? If I start at point A, I am making 4 Halloween costumes and 0 fanny packs. I don't know why I'm stuck on this fanny pack thing. I don't know. I think they're cute. So what is the opportunity cost if I suddenly am making 4 Halloween costumes and 0 fanny packs to point C where I'm making 2 fanny packs? how many Halloween costumes did I have to give up because I don't have enough resources? Let's see. A to C. We start out making 4 Halloween costumes and 0 fanny packs. All of a sudden, we move from 2 2 Halloween costumes and 2 fanny packs. So from 4 down to 2, what have we lost? We lost 4 minus 2 is 2 Halloween costumes. So I'm going to write 2 costumes. Excuse my horrible handwriting. I feel like I haven't written anything down since March. I've just been typing. All right. So 2 costumes. Every time we do a PPC or graphing and it asks us a question, we need to label what the answer is. I can't just say 2 because then I'm going to be like, 2 what? 2 dogs? 2 cats? 2 tickets to a Green Bay Packers game? No, I have to label 2 costumes. Okay. Number 3, I'm going to do in this reddish, orangish pen. Okay. So from point E to point D, let's label where we're going. From E, we're going this way up to D. What is the opportunity cost of 1 Halloween costume? Okay, so we start out at point E. What are we making? We got to ask ourselves, what are we making at point E? At point E, I'm making 4 fanny packs and 0 Halloween costumes because I'm on the 0 line for Halloween costumes. Okay? If I move from point E to point D, now I'm making at D 3 fanny packs and 1 Halloween costume. So what did I have to give up? I had to give up 4 minus 3 is 1 fanny pack. So over here, the answer is 1 fanny pack. And I have to label my answer. So the opportunity cost, what I had to give up to make 1 Halloween costume, was 1 fanny pack because I don't have enough resources to do both. All right, we're going to move on to the next problem in just a second. All right, next problem. Here we go. Now we are comparing churros, which is a delightful Mexican fried dessert with cinnamon, and cinnamon rolls, which is America. What we eat for breakfast, right? So only in America would we eat sugary bread with icing on it for breakfast. So let's practice again. And this one has a few more problems. So I'm going to walk you through it again. So red pen is going to be my first problem if you're following along with my colors. From point A to B, so I'm going to circle, I'm going from point A to B. What is the opportunity cost of making 1 cinnamon roll? We know churros and cinnamon rolls are made out of the same thing. Bread dough, some icing, lots of sugar, some flour. So this is constant cost. It's a straight line curve made of the same resources. So if I'm going from A to B down the constant cost line, what is the opportunity cost of making 1 cinnamon roll? So where do I start out with? What point am I starting out with? A. At point A on this graph, I'm making 25 churros. Yum. And 0, Miss Keller, my goodness, why didn't you put a 0? 0 cinnamon rolls. So I don't have the resources to make any cinnamon rolls if I'm going to be making 25 churros. But I want to move to point B, where I am going to make some cinnamon rolls. So at point B, if I move from A to B, then I'm now making 20 churros and follow the line, 1 cinnamon roll. So what's the opportunity cost of that 1 cinnamon roll? If I make 1 cinnamon roll, how many churros am I losing? Let's go and see. What is, from point A to point B, 25 minus 20? It is 5 churros. Okay, let's switch colors here. Let's go to this pretty blue color. All right, I'm going to use blue for number 2. From A to C, what is the opportunity cost of 2 cinnamon rolls? Real quickly, A to C, we're moving down the line here. What is the opportunity cost of 2 cinnamon rolls? Where do we start at A? We start with 25 churros and 0 cinnamon rolls. But we end up at point C at 15 churros and 2 cinnamon rolls. And that's what the question is. What is the opportunity cost of 2 cinnamon rolls? So how do I get from here to here? What have I lost in churros? Let's find out. From A to C, how many churros did we lose? 25 minus 15 is 10 churros. I feel the need to apologize for my handwriting again. Sorry. Okay. Let's do one more. Actually, I lied. We're going to do a ton more. Number 3, I'm going to do in this purple color. Here we go. From point E to point D. Look at that. We are moving this way now, just like we did in our last problem. From point E to D, moving up the constant cost curve, what is the opportunity cost of 1 cinnamon roll? This is where it gets tricky. You look down here, you don't see a 1. I see 4 and 3. But it's the same thing because the difference here is 1 cinnamon roll, right? So from point E to D, what is the opportunity cost of 1 cinnamon roll? Well, let's see. We start out at E making 4 cinnamon rolls, yum, but only 5 churros, which makes Miss Keller sad because churros are way better. We move to D where we're making 3 cinnamon rolls and 10 churros, which makes Miss Keller happier. So how many churros did we gain by taking away this 1 cinnamon roll? The opportunity cost is we lost 1 cinnamon roll. What is the opportunity cost of that 1 cinnamon roll? How many churros? We go over here. What's the difference between 10 and 5? 10 minus 5 is 5 churros. And let me explain something really quick. Do you see why this is a constant cost? When we are giving up 1 cinnamon roll, every single time we're losing 5 churros. That's a constant ratio. 1 cinnamon roll always equals 5 churros on this graph. So we go from 1 to 2 cinnamon rolls. If we go from B to C, how many churros have we lost? 5. If we go from C to D, 2 to 3 cinnamon rolls, how many churros have we lost? 5. Let's say we go from F to E. We go from making all cinnamon rolls to 4 cinnamon rolls. What do we gain? 5 churros. Always, 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 if you're going from one point to the next, it's 5 cinnamon rolls. Well, then how did we get 10 over here? Look, we went from A to C. A to C, that was 2 points. Hop, that's 5 churros. Hop, that's 5 churros. Okay? All right, let's continue with this one. All right, I'm going to fly through these, and I had to add to my color stash. So number 4, I'm going to be doing in this beautiful blue color, one of my favorite colors. Number 4. Really, really fast. I'm going fast. You got to keep up with me now. From point C to A, what is the opportunity cost of making 10 churros? C, we're making 2 cinnamon rolls and 15 churros. All of a sudden, we hop to A. We're making 25 churros and 0 cinnamon rolls. Gosh, dang it. Put a 0 there, Miss Keller. Okay, so now we're hopping this way. We are losing cinnamon rolls, but gaining churros. And it says 10 churros. How many cinnamon rolls could we make with the dough of 10 churros? Let's see. So we lose 10 here. What about the difference here? 2 minus 0 would be 2, right? We always label our work. I'm going to put 2 cinnamon rolls because I'm lazy. 2 cinnamon rolls. All right, switch colors. Keep up with me, friends. Pink, my actual favorite color. Number 5, from point F to point C. Holy crap, Miss Keller, that was a jump. Also, we're going up, 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 up. Wow, this pen is awful. Let's try again. All right, from A to C, F to C, I didn't click this. Duh. From point F to C, what is the opportunity cost? Uh-oh. We got to know from point F to point C, what have we lost or gained? At point F, we started with 5 cinnamon rolls and 0 churros. Make me want to cry. If we jump to point C, we're now making 15 churros, but how many cinnamon rolls have we lost? We just do some math here. 5 minus point C was 2 cinnamon rolls. What is 5 minus 2? It is 3 cinnamon rolls. All right. Hopping on. Blue for number 6. Blue for number 6. What is the opportunity cost of 1 cinnamon roll? So Miss Keller didn't give you any points here. What the crap do we do? Don't worry. Never fear. You know what to do here. The opportunity cost of 1 cinnamon roll. So let's just start with 0. Let's say that we are making 0 cinnamon rolls. And if we're making 0 cinnamon rolls, we have the resources and we are making 25 churros. If we suddenly decide, I need to make less churros and maybe 1 cinnamon roll, we're hopping from 0 to 1 cinnamon roll. How many churros did we lose? What did Miss Keller say on the other side of this? We said that no matter where on the graph we are, 1 cinnarole equals 5 churros. And that's a ratio. No matter where we are on this straight line constant cost graph, 1 cinnamon roll equals 5 churros. So what's the answer? 5 churros. Yum. Okay. All right. Number 7. Here we go. I know you're getting bored with me. Red. Number 7. Starting at point B. Ooh, Miss Keller gave us a point this time. I want to make 3 more cinnamon rolls. I don't know why. Churros are way better. What is my opportunity cost? So I go to B. I'm making 1 cinnamon roll. But I want to make 3 more. 1, 2, 3. Now I'm at point E. So I'm going from point B down to point E. What is my opportunity cost? I'm making more cinnamon rolls. How many churros am I losing? Let's see. At first, I'm making 1 cinnamon roll and 20 churros. Then all of a sudden, I'm down to 4 cinnamon rolls and 5 churros. How many churros have I lost? 20 minus 5 is 15 churros. I hope you're catching my drift here. All right, last one. I'm sorry, I'm killing y'all. Number 8. Number 8 in purple. Starting at point E, right here. I want to make 20 more churros. What is my opportunity cost? Okay, this one's a little bit harder, a little bit more math, but it's all in 5s. So I'm at point E. I'm making 4 cinnamon rolls and 5 churros, but I want to make 20 more. So I got to add 20 to 5 and go up. Well, luckily 20 plus 5 is 25. So I'm hoping to move up here in the yummy zone where there are more churros and less cinnamon rolls. So now this question is basically asking me without asking me, how did I get from point E to point A and what am I losing? So E to A, we're moving up the constant cost line. What is the opportunity cost? I was making 4 cinnamon rolls and 5 churros. Now I'm moving to 25 churros. How many cinnamon rolls? 0. No cinnamon rolls, the way God intended. So what is my opportunity cost from 4 to 0 cinnamon rolls? Oh, I'm sorry, you couldn't see that. From 4 to 0 cinnamon rolls, the opportunity cost is 4 minus 0, 4 cinnamon rolls. I'll write it out this time. All right. Now that I have thoroughly confused you, and I know I have, I'm going to be linking this video in another formative assessment for you. I want you to try it out. If you fail miserably, I understand. This is hard stuff. That's why you can go back and watch this video anytime. I'm going to be linking Mr. Sayre's videos because he explains things in a little bit different way as well. So, give me 1 second. I'll hop back on here. All right. So what happens if you are trying to find out the opportunity cost, but it's not quite on the graph? That's where we have to use ratios, okay? So how do we do that? So let me get this stuff out of the way. And click right here. What if the number you need to figure out on opportunity cost isn't on the graph clearly or at all? And here's what I want you to write down, this bit right here. So this is called finding opportunity cost with a ratio instead of just finding it on the graph, okay? So the first thing we need to do is figure out what the question is. What are they asking? They're asking, what is the opportunity cost of 2 churros? So we're looking at this. I'm looking at these numbers. They go 5, 10, 15, 20. There's no 2 in there for me to find. 10 minus 5 is 5. 15 minus 10 is 5. And I can't just wing it and be like, 2 is like kind of right here, so I'll just go this way. That's not the way it's done. We have to do a ratio. So how do we do that? We find the ratio of one good to another and set it up as a fraction. And that's what I've done here. 1 cinnamon roll always equals 5 churros on here. Then we fill in the known amount from the question. The question said, what is 2 churros? On this side, we put 2 churros. And because we are trying to find out how many cinnamon rolls we have to give up or gain for that many churros, we fill in X for an unknown amount. This is basic algebra. Then we cross multiply and divide to solve for X and check the graph to see if we're close. So let's actually do this. I know that that's a lot of talking and you're probably scared. So I'm going to open up my document camera here. I'm going to be working with a blue pen because I feel like blue today. So here we go. So I know that one cinnamon roll, if I go from 0 cinnamon rolls and 25 churros, I'm making 25 churros and 0 cinnamon rolls. If I move to 1 cinnamon roll, now I'm at point B. How many churros did I lose? 25 to 20. That is 5. So we know that the ratio on this, and if we check it, well, that's 5 churros, and that would be 1 cinnamon roll, and that's 5 churros, and that would be 1 cinnamon roll. The ratio is always, on this graph, 1 cinnamon roll is equal to 5 churros. So we set that up as a fraction, 1 cinnamon roll over 5 churros. Then it says, fill in the known amount from the question. What is the question? What is the opportunity cost of 2 churros? Sorry, you can't see it. It's on the screen right here. 2 churros. So I want to know 2 churros. And when we do this, we always keep the same good or service on the same row. Okay, so churros is on the bottom over here. We need to put churros on the bottom over here. Then we want to figure out, well, how many cinnamon rolls am I giving up or gaining here? What is our opportunity cost in cinnamon rolls? But we don't know that, so we're going to make it a variable. Think back to your algebra classes, a variable. We'd fill it in with a letter. We're going to use X. Then we cross multiply and divide. Cross multiply this way. X times, well, let's start this way. Sorry. 1 times 2 is 2. Very good. X times 5 is 5x. Now, how do we divide? Cross multiply and divide is how we do it. We want to get the variable alone. We want to get the x alone to find out what it equals. We divide by 5. What we do to one side, we got to do to the other. Divide by 5. 2 over 5. You can leave it as a fraction, or you could pop it into your calculator and make it a decimal. Just a quick review. I know you know this. Y'all are smart. Your calculator, I'm going to use my phone. In class, we don't use our phones, but on NTI, I completely understand. So I'm going to take 2 divided by 5, right? Because that's my fraction, 0.4. And we always label. We were looking for cinnamon rolls, 0.4 cinnamon rolls, okay? So let's click through and go to the next one and do it as well, okay? So let's look at it first before we go through it. We are asking, Ms. Keller is asking, what is the opportunity cost of 8 churros on this graph? I'm looking at the graph and I'm like, okay, I see 5, I see 10, I see 15. I don't see the number 8 on here at all. So how am I supposed to find out how many cinnamon rolls I'm giving up for 8 churros? We have to do a ratio. So let's do this ratio together. And I'm going to pull my document camera a little bit larger for you to see now. So we need to find the ratio of one good to another. We do that by just taking a look at the graph. If I'm making 0 cinnamon rolls, I start out at 0 cinnamon rolls and 25 churros, but I suddenly move to 1, then I'm moving down in churros. How many churros did I lose? 5. I check it here and I'm like, is it 5 between every one? Yes, it is. Is it 1 between every one? 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1? Yes. So our ratio stayed the same on this graph. It is still, for every 1 cinnamon roll, we're giving up 5 churros. Or for every 5 churros, our opportunity cost, we're giving up 1 cinnamon roll. Ratio is the same. Now, what is the question asking? Look up here at the pink again. What is the opportunity cost of 8 churros? So I filled in my 8 churros. I want to know how many cinnamon rolls equals 8 churros in resources. And I don't know how many cinnamon rolls, so I fill in X for the unknown amount. Cross multiply. 1 times 8 is 8. X times 5 is 5x. Now I need to divide, get the variable alone. I'm trying to find out what that X is. 5. What we do to one side, we must do to the other. 5 divided by 5, nothing. Well, it's 1. And then 8 divided by 5. And if we plug that into our handy-dandy calculator, it would be 8/5. You can leave it as a fraction, or 1.6 cinnamon rolls. Let's see if we're right, okay? So we can look at the graph and kind of like guesstimate what that might look like. So let's say we're looking for 8 churros, right? That's what the problem asked us. 8 churros would be like, here-ish, right? Let's follow that and pretend that we make this little dotted line. Oop, we hit the line. And we go down, 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 down. Okay, so let's say we started from here and we moved and made more churros. We move up the line, we're moving closer to churros, we're making more churros. We should have given up 1.6 is what our problem is. Is 5 to like here-ish? 1.6? This would be 1. This is over half. So yeah, this looks like 1.6-ish. So we know that we've probably done this problem right because we were able to check it on the graph. Okay? All right. Oh, Miss Keller, that's a lot of work. I'm not sure I'm able to do that. That's okay. Miss Keller's here to save the day. So let's take a look at this graph. Same graph, same ratio, okay? So what is the opportunity cost of 7 churros? We're looking at this graph. Let's find out, number 1, what the main ratio is. How many cinnamon rolls equal how many churros? How many cinnamon rolls can we make, and how does that equal how many churros we give up? So the opportunity cost, if I am making 0 cinnamon rolls and 25 churros, but I want to move down to making 1 cinnamon roll, I move down to 20 churros. That's 5. What if I do it again? That's 5. What if I do it again? That's 5. What if I do it this way? That's 1. What about this way? 1. Let's do it again. 1. You see what I've done? I know that 1 cinnamon roll always equals 5 churros. So I'm going to write that over here. 1 cinnamon roll always equals 5 churros. So that is going to be my ratio all the time. And we always want to label. So let's look at number 1. What is the opportunity cost of 7 churros? Well, we know that the first ratio, we know the first ratio is 1 cinnamon roll. And I'm going to put 1C because I don't want to write out cinnamon roll. And 5 churros. Okay? That equals, they want us to find 7 churros. Always put like terms on the same part of the fraction. So I'm doing churros on the bottom. I want to keep my churros on the bottom. But we don't know how many cinnamon rolls. Ruh-roh. So we put in a variable. Cross multiply. 1 times 7 is 7. 5 times x is 5x. Okay? How do we get rid of that 5? We divide it. What we do to one side, we must do to the other. 5 divided by 5 is 1. So we just get rid of it. And this is 7/5. We can leave it as a fraction. Oh, there's my little boy. We can leave it as a fraction and say that the answer is 7/5 of a cinnamon roll. Cinnaroll. Or we could say 7 divided by 5 is 1.4. So that is number 1. Okay? Here's what I would like for you to do. I would like for you to do number 2, 3, and 4 and have them in your notes for me, okay? So go ahead and try those right now before I show you the answers. Pause this video and go try them. All right, hopefully you have worked with numbers 2, 3, and 4 like I asked, and let's take a look at the answers. Number 2, the answer was 6.5 cinnamon rolls. 6.5 cinnamon rolls, okay? Number 3, one second. All right, number 2, I mixed it up on you. You got to watch out for me. So I asked you on number 2, what is the opportunity cost of number 3, of 1.5 cinnamon rolls. So now our unknown variable is on the bottom, okay? So we had to fill in x for that unknown variable, okay? So the answer for number 3 was 2.5 churros. All right, let's take a look at number 4. 1 cinnamon roll over 5 churros. Again, we're looking for that unknown variable, which is churros this time. The answer is 18.75. So hopefully you worked these out and you got them correct. We're going to be doing some formative assessments to figure out whether or not you've got this under control, okay? Let's make sure that's the end. If you need extra help, I'm going to be linking Mr. Sayre's extra help video right here. So you will be in good shape, I promise. contact me, meet me on Google Meets, text me, or email me if you have any problems with these difficult concepts. And trust me, I understand they are difficult. All right, guys, have a good day.